Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 12 students and the topic of discussion is determinants. In this video, we'll be focusing on NCERT solutions for the miscellaneous problems. In the first problem, we need to show that this determinant is independent of x. So let us try to show that this determinant, let it be A, is independent of theta, not independent of x, independent of theta we need to show. So we can write mod A, we can expand the determinant x minus x1 1x minus sine theta minus sine theta 1 cos theta x plus cos theta minus sine theta minus x cos theta 1. So this is minus x square minus 1. So x into minus x square minus 1 minus sine theta. This will be minus x sine theta minus x sine theta minus cos theta plus cos theta minus sine theta plus x cos theta. So we expand this. Let us put mod A equal to minus x cube minus x. We have expanded this. Now we expand this plus x sine square theta plus sine theta cos theta minus cos theta sine theta minus x plus x cos square theta. So this will get cancelled. We have now this expression here, x is also there. So it will be minus x cube minus x plus x sine square theta plus cos square theta. This will be 1. So only x will remain. So this will be minus x cube minus x plus x. This will go minus x cube. So which is independent of theta. Now we need to evaluate this determinant. Let it be A. We call it as A equal to. So now that A cos alpha cos beta 0 sin alpha sin beta cos alpha minus cos alpha sin beta minus sin beta 0 sin alpha cos beta cos alpha minus sin alpha minus sin beta cos beta sin alpha cos beta sin alpha sin beta. So we expand this. This will be cos alpha cos beta. When we multiply with cos alpha cos beta, it will be cos square alpha cos square beta. This will be 0. So this will be again sin beta cos alpha sin beta cos alpha plus cos square alpha sin square beta. This term will be 0. Sin beta So this will be plus sine square alpha sine square beta plus sine square alpha cos square beta. So we can take in this two expression, we can take it as cos square beta cos square alpha plus sine square alpha plus sine square beta. Again in these two expression we can take sine square beta common, we get cos square alpha plus sine square alpha. So this will be cos square beta plus sine square beta into cos square alpha plus sine square alpha. This is 1, this is 1, 1 into 1 is 1. So determinant of A is 1. A inverse is given and we need to find AB inverse. AB inverse is B inverse A inverse. We already know A inverse is given here. We need to find first B inverse. So how do we get? First we do let B. Let B is 1 into 3 0 minus 2 1 minus 2 minus 1 0 0 1 minus 2 minus 1 3 0 minus 2, and this is evaluated to be 1. Now cofactor, to get B inverse we need to find cofactor matrix. That I leave it an exercise to the reader. In the previous videos we have explained how to get the cofactor matrix. They should be able to get this matrix 3 1 2 2 1 2 6 2 5. With this now we can get adjoint B, which is cofactor matrix transpose, and B inverse will be 1 by P adjoint B. So B inverse will be 3 1 2 2 1 2 6 2 5. Basically we have taken transpose of this matrix is coming here because that B is 1, so B inverse is nothing but adjoint B. So this is adjoint B as well as this matrix is adjoint B as well as B inverse. Now we can get B inverse A inverse. That's what we wanted to get from here. That is our problem statement. So we multiply this 3 1 2 2 1 2 6 2 5. A inverse will be 3 minus 1 1 minus 15 6 minus 5 5 minus 2 2. So on multiplication we get this as 9 minus 3 5 minus 2 1 0 1 0 2. So this is our final answer. We need to verify adjoint A inverse is equal to adjoint A inverse and A inverse inverse is equal to A. So what we'll be doing, we will take a 2 by 2 matrix. Let A equal to 1 2 3 4. We have assumed some matrix and we want to show this identity. So adjoint A for a 2 by 2 matrix we know. We'll shift these two numbers 4 1 and change the sign of these two, minus 2 minus 3. We call this as say B. Since we want to find adjoint A inverse, we need to find B inverse. We need to find B inverse to be found. For that, let us find mod B first, or det B. Det B is 1 into 4, 4 minus 6 equal to minus 2. So B inverse will be equal to adjoint B by mod B equal to minus 1 by 2, and adjoint B is B we got, so adjoint B will be changing this, so adjoint B will be A itself. 1 2 3 4. So we got the first part, adjoint A inverse, we got this. This is equal to adjoint A inverse. So now we'll get the adjoint A inverse. So A inverse is 1 over det A adjoint A det A is 4 minus 6 equal to minus 2, and adjoint A is 4 1 minus 2 minus 3. So A inverse will be minus 1 over 2, 4 minus 2 minus 3, 1. This is A inverse we got. Now we want to find adjoint of A inverse. So adjoint A inverse 1 4 2 3. Adjoint A inverse. A inverse is minus half also there. So minus half will also come here. 1 2 3 4. But this is nothing but adjoint A inverse that we have computed here. So these two are same. Hence proved. In this problem, we need to evaluate the determinant given by this expression. We call it as A. So now we can evaluate that A equal to X. Take the first element, ignore that rows and columns, and get the balance elements. So X plus Y, X, X, Y. Then take the second element with a negative sign. Similarly, ignore those rows and column, Y, X, X plus Y, Y. Y, X, X plus Y, Y. Next we have minus X plus Y, Y, X plus Y, X plus Y, X. So we got mod A, determinant A as this. Now we expand this. So X can be multiplied with X plus Y into Y minus X cube minus Y cube minus plus YX into X plus Y minus XY X plus Y and plus x plus y the whole cube. On further simplification of this, we can get this that as minus 2 x cube plus y cube. This is the final answer. We need to solve this. Again, we call this as a, and that a can be easily computed 1 into x plus y y x plus y minus x 1y 1x plus y plus this is x plus y 1x plus y 1x. So this will be x plus y the whole square minus xy. So minus x into x plus y plus xy plus xy plus y into minus y into x plus y. So we have to expand this. So let us expand x square plus y square plus 2xy minus xy minus x square minus xy plus xy plus xy minus xy minus y square. So this will get cancelled, this will get cancelled, only xy will remain. So determinant A is xy. Now we need to solve the system of linear equation. Instead of now conventionally we used to have x, y, z, but here 1 over x, 1 over y and 1 over z is there. So but the coefficient will remain same. So we can write this as 2, 3, 10, 4 minus 6, 5, 6, 9 minus 20. So x is not 1 over x here. So 1 over x, 1 over y, 1 over z. Now to solve this, this is of the form Ax equal to b, x will be equal to A inverse b. So we need to find A inverse first. So for that we have to find that A 2 minus 6, 5, 9 minus 20 minus 3, 4, 5, 6 minus 20 plus 10, 4 minus 6, 6, 9. So on solving this we get this as 1200. So here we directly write the A inverse matrix. A inverse equal to 1 by det A adjoint A equal to 1 by 1200 75 50 75 110 minus 1 1 10 72 0 minus 24. So how we got this matrix? This is the adjoint A which you should get from the matrix A and det A. that you know how to do it. So this is an example for you to get this number. Now we got A inverse, but this is not the solution. We have to multiply with B to get X. So that's what we are going to do next. So X will be equal to A inverse B. A inverse is we have already computed, 1/1200. 75, 150, 75, 110 minus 110, 10, 72 0 minus 24, 412. So on multiplying this, we get X as 1/2, 1/3, 1/5, but X is 1/x, 1/y, 1/z. So this is equal to 1/2, 1/3, 1/5. This implies X equal to 2, Y equal to 3, Z equal to 5. This is the final answer. Now in this problem we need to show, first get det A and see which option is correct out of the MCQ problem. So let us find det A first. Det A equal to 1 into 1 sin theta minus sin theta 1 minus sin theta minus sin theta minus 1 1 plus 1 minus sin theta 1 minus 1 minus sin theta. We can expand and get det A as 2 1 plus sin square theta. Now we know that sin theta lies between 1 and minus 1. So now what is the value it can take? Det A, we can see different option. This is not correct. Det A is some value is there. It is not equal to 0. But it takes which range that we want to check. Now this can maximum be 1. If it is minus 1 also, this will be 1. So 1 plus 1 2 4. So maximum value will be 4. Maximum will be 4. What is the minimum value? Minus 1 also it will remain 4. Let us take 0. 0 means this will be 2. So minimum value of det A is 2. So the option 2 and 4 both are inclusive. So we will get D as the correct option. Friends, with this we conclude this video. Please like and subscribe my channel so that in future more videos can be released to you instantaneously. Thank you very much, friends.